Hello everyone, welcome to our channel. Today we're going to talk about Docker and why we should use Docker. The question is, why Docker? Understanding Docker and its advantages. Docker is a powerful platform that has revolutionized the way software is developed, shipped, and deployed. Since its release in 2013, Docker has gained immense popularity among developers, system administrators, and IT professionals due to its ability to simplify complex environments, enhance application portability, and streamline the software development lifecycle. Understanding why Docker is so valuable and the merits it brings can help businesses and developers leverage its full potential. What is Docker? Docker is an open-source platform that automates the deployment, scaling, and management of applications within lightweight, portable containers. Containers are isolated environments that package an application along with all of its dependencies, libraries, and configuration files, ensuring that it runs consistently across different computing environments. Docker containers are based on Linux kernel features such as namespaces and groups, which provide isolation and resource management capabilities. Why Docker? The key motivations. Simplified development and deployment. Docker allows developers to package an application and its dependencies into a single container, ensuring that the application behaves the same way in different environments. Whether on a developer's local machine, in a testing environment, or in production. This eliminates the common "it works on my machine" problem, where software behaves differently across environments due to discrepancies in configurations, dependencies, or operating systems. Portability across platforms. Docker containers can run on any system that supports Docker, whether it's a developer's laptop, an on-premise data center, or a cloud environment like AWS, Azure, or Google Cloud. This portability ensures that applications can move seamlessly from one environment to another without requiring changes to the code or environment configurations. Efficiency and resource optimization. Unlike virtual machines, VMs, which require a full operating system instance for each VM, Docker containers share the host system's OS kernel. This makes containers much lighter and faster to start, with significantly reduced overhead. As a result, Docker can run many more containers on a given piece of hardware compared to VMs, leading to better resource utilization and cost savings. Microservices architecture support. Docker is an ideal platform for developing and deploying microservices. In a microservices architecture, an application is broken down into small, loosely coupled services that can be developed, deployed, and scaled independently. Docker containers can encapsulate each microservice, making it easier to manage dependencies, scale services individually, and update them without affecting the rest of the application. Version control and collaboration. Docker supports versioning of containers, allowing developers to track changes, roll back to previous versions, and collaborate more effectively. Docker images, the blueprints for containers, can be stored and shared via Docker Hub or other container registries, making it easier for teams to collaborate on projects and share standardized environments. Continuous integration and continuous deployment, CI/CD. Docker integrates seamlessly with CI/CD pipelines, enabling automated testing, building, and deployment of applications. By using Docker, teams can ensure that the same environment is used throughout the development pipeline, from coding to testing to deployment. This consistency reduces the chances of deployment issues and accelerates the software release cycle. Isolation and security. Docker containers provide process and file system isolation, ensuring that applications run in a sandboxed environment. This isolation reduces the risk of conflicts between applications and improves security by limiting the impact of potential vulnerabilities. Additionally, Docker supports the use of security best practices such as image signing, vulnerability scanning, and runtime security measures. Scalability and orchestration. Docker supports container orchestration tools like Kubernetes, Docker Swarm, and Apache Mesos, which allow organizations to manage large clusters of containers at scale. These tools automate tasks such as container deployment, scaling, load balancing, and monitoring, enabling organizations to run highly available and resilient applications in production. Merits of Docker consistency. Across environments, Docker ensures that an application runs consistently across different environments by packaging everything the application needs into a single container. This consistency reduces the risk of bugs and deployment issues caused by differences in environments, making it easier to develop, test, and deploy applications. Speed and agility. Docker containers are lightweight and can start in a matter of seconds, compared to the minutes it can take to boot up a virtual machine. This speed allows developers to iterate quickly, run tests faster, and deploy updates more frequently, leading to faster development cycles and quicker time to market. Resource efficiency. Docker allows multiple containers to share the same host OS, reducing the overhead associated with running multiple instances of an application. This efficiency allows organizations to run more applications on the same hardware, reducing infrastructure costs and maximizing resource utilization. Simplified dependency management. Docker eliminates dependency management issues by packaging all dependencies within the container. This means that developers don't need to worry about conflicts between different versions of libraries or tools, as each container has its own isolated environment. Improved collaboration and DevOps practices. Docker fosters collaboration between development and operations teams by providing a standardized environment for running applications. This standardization supports the DevOps culture, where development, testing, and operations teams work together to deliver software quickly and reliably. Enhanced security. Docker containers are isolated from one another and from the host system, reducing the attack surface and limiting the impact of potential vulnerabilities. Docker also supports security features such as image scanning and container runtime protection, helping organizations secure their applications. Easy scaling and orchestration. Docker's support for container orchestration tools like Kubernetes makes it easy to scale applications horizontally by adding more container instances. Orchestration tools also provide features such as automated failover, self-healing, and rolling updates, which enhance the reliability and availability of applications. Flexibility and integration. Docker integrates well with various development tools, CI/CD pipelines, and cloud platforms, providing a flexible and adaptable solution for different use cases. Whether an organization is running on-premise infrastructure or leveraging cloud services, Docker can be easily integrated into existing workflows. Docker has become a cornerstone of modern software development and deployment due to its ability to simplify complex processes, enhance consistency across environments, and improve resource efficiency. Its merits, such as portability, scalability, and security, make Docker an essential tool for organizations adopting DevOps practices, microservices architectures, and cloud-native applications. By embracing Docker, businesses can achieve faster development cycles, more reliable deployments, and greater flexibility in managing their applications. Thank you so much for watching our video, and kindly subscribe if you haven't, and like the video. Happy learning!